Kamau Wanguhu. I'm actually based out of the Netherlands, but I'm not Dutch. I recently moved into integration engineering, which is part of, or used to be part of the R&D group. And what I'm currently tasked on is coming up with a definition for what an app envelope is supposed to be. And by an app envelope, I'm talking about the definition in terms of how you would define an application in such a way that you can move that application, and you can also take that application and put it into a different environment. So what I was going to talk about today is what you would think of as a virtual appliance currently, but how would you take that virtual appliance and make it portable, right? So I'll start off by going over the current definitions that people have within the different platforms that VMware supports of defining an application. And when I say an application, or I refer to it as a VApp, just think of it as an encapsulated application, where an application is a collection of virtual machines and the definition of how those virtual machines interact with each other. All right? So we'll start off with the vCenter and VCD applications and how those are defined and encapsulated, and then I'll go over a bit on how it's done with blueprints with VCAC, as well as App Director, just sort of a quick overview of it. And then I'll quickly talk about the future of VApps, at least from my point of view and from the group of people that I'm working with to come up with an internal definition. So think of it as nothing that you're going to go out and apply today, but as something that we are working with internally inside VMware and inside the engineering groups to come up with a good definition of how you would actually encapsulate that application. So if we start off with vCenter and VCD applications, a good format for interchanging of applications, or in this sense, a VM encapsulation, is the OVF format. And the OVF format is a standard that has been out there defined within the IETF that allows you to describe what a VM does within the application, what the requirements for that VM are, and actually describes how to put that virtual machine together within an environment. The thing to remember about an OVF format is that it's a deployment format. In other words, you have to take that definition that is put inside the OVF and convert it into a runtime environment that works for the platform that you're going to put it in. Meaning that if I take an OVF and implement it or import it into a vCenter environment, there is different things that are available within vCenter, as opposed to if I take it and import it into, and say, an Amazon environment, or even a VCD environment. So you think of the description of that OVF and the application embedded in it as a deployment description, but as soon as you deploy it, a lot of those information that are embedded in the OVF are gone. Some of them are still available within the environment. Some are retained by the platform that you put it into. But in reality, since it's a deployment environment, it's supposed to be deploy, forget about the OVF environment. So the big advantage with OVF is that it is extensible, meaning I can extend the definition to include other things that I would want to be able to define within the application. And within the OVF description itself is a properties, and those are the attributes that you want to retain. So something like, I define a property as the OVF builder or deployer of the application, and I say I need an IP address from the user, I need a subnet mask, I need a gateway, basic things like that. When you deploy that OVF, it takes those parameters and requests input from the user. And the input that the user provides is put into what is known as the OVF environment. The OVF environment is, if you're familiar with, say, a Unix environment, is a place where you put information that other applications can get hold of. Within the OVF environment, it is made available to the application or the VM itself, but in most cases you need glue code written and injected into the virtual machine itself that will help you retrieve that information from the environment. So one example is, especially with IP addressing, you will go out and you'll give this information during the OVF deployment. That information will be stored in the environment. There'll be glue code that runs within the virtual machine that is usually embedded in the tools, and it'll pull that environment into the application that needs it within the OS. In this case, it'll be the basic OS that will use it to configure its networking for it. So that's the OVF description. And an example of some of the properties, like I was saying, and how you would input them, and this is within Virtual Center itself during the deployment phase. The other option of how you can customize a virtual machine is using guest customization, and this is what we've all been doing for a while. The only problem with guest customization is that it has a limited set of predefined attributes that you can configure, and it also has a fixed user interface. So it's not as flexible as the OVF platform, but it does give you another way of sidestepping into the virtual machine to actually do configurations for it. Also with guest customization, you need to be able to inject the scripts within the OS, but since a lot of the guest customization, say with Windows, comes with those scripts already in the environment, you have nothing that you really need to do. You just need to be able to provide those attributes to the OS to pull in. So as a quick recap on OVF, it is a distribution format, and it has a lot of extensibility and gives you the way of providing information into the virtual machine. Studio, VM Studio, which gives you the capability of creating OVFs and applications, does provide tools for you to be able to inject those scripts into the OS itself. And guest customization is a way for doing deployments when you're using VCD or VC. So to extend the whole OVF format to include multiple applications, we are coming up with, or there is a definition for a VApp. And the VApp definition is different in VC as it is in VCD. And I'll cover the VC one here. But the container allows you to manage a collection of VMs as one single entity. It gives you a way of powering and powering off the whole VApp. It provides things like boot order so that you can boot your application in the correct format and the correct process. It also has a shared environment. Kind of like the OVF environment, it has a shared environment within the VApp definition that allows virtual machines to discover attributes about other components within that VApp. Unfortunately, or fortunately, it's built as a resource pool, and as such, a VApp cannot go beyond the limits of that resource pool. Within VCD, though, there is also a VApp construct, but it's very different from the one that's used by VC. As opposed to the VC one, where you can have embedded VApps within VApps, in VCD you can only have a flat VApp. And there is no VApp-wide resource limit, so you can't limit the resource consumption of your VApp, but you have to limit it on a VM by VM basis within the VApp definition itself, because the VApp construct spreads across the whole VDC. So no nested VApps, and there is limited support for the shared VApp environment that we were describing for how to discover other attributes within the virtual application. Another option that we have is something called the vServices. How many of you are familiar with vServices or have actually interacted with vServices? Nobody. Wow. So vServices, I think, is one of those really well-hidden secrets within Virtual Center. What it allows you to do is create dependencies on deployments of virtual machines. It creates what you might think of as a client-server kind of interaction between your virtual machines and your environment. So you can have things like servers that are embedded within Virtual Center that provide certain services. So as a good example, you can have a vService registered with Virtual Center that provides database services, so that when a virtual machine gets deployed, all it has to say is, I want to subscribe to a database, and these are the components of that database that I'm interested in. Once it's deployed, it'll be bound to that vService, and you'll be able to get the database services without having to say what kind of a database it wants or how it wants to interact with it, right? That is a client-server kind of basis. The flexibility that would give you is the fact that you can move between different platforms that support vServices and subscribe to the vService and still have the same kind of access and bindings that you would have if you are deploying it within Virtual Center. Okay? So like the example I was giving was you can bind to a database, you can create that database. When the VApp gets deployed, it just has to request from the deployer what are the database login credentials that you're interested in, and it goes in, creates the database for you and provides you that database, provides you the login access that you requested from the user as well. The other big advantage of it is that it's not only bound at the initial deployment, but you can rebind and you can add bindings even after the fact. So vServices is very popular. The only problem that I have seen with it is the fact that it hasn't been widely deployed or consumed within the VMware platforms that are available. It is currently only available within vCenter, which kind of limits the scale of it. And we'll talk about some of those problems later. So VCAC applications. How many of you guys have used VCAC? 1, 2, 3. Okay, so not very popular in Italy. What would you say are some of the issues or why you haven't deployed VCAC? Or why have you deployed VCAC? You are deploying right now? Okay. And by the way, I have Fabio over here. If you feel like shy and you don't want to ask me questions in English, Fabio will translate for me, and he can translate both ways, which is good. So don't be shy. Originally, when I was putting this session together, I wanted it to be an interactive roundtable, because what I'm really looking for is use cases from you guys in terms of how you would use applications. And by applications, I'm meaning being able to define that application encapsulation so that you have a portable application that you can move within all our platforms as well as outside our platform. Because that will help me come up with a better definition and a better use case definition so that I can create a much better platform for you guys. So don't be shy, ask me, and provide feedback as much as you can. So for VCAC, it uses a different construct as opposed to the VApps that we're used to. And part of that is VCAC was an acquirement. So we bought a company that came in with a product, and they had their own way of defining how you define applications. And their process is a blueprint process. It is a specification provisioning, and it's used not just for virtual machines, because the original platform was not meant just for virtual machines, but can be used for deploying physical machines as well. And it can also provide characteristics that are required for the deployment of those virtual machines, and that includes things like policies and definitions of attributes that go into those machines themselves. You can end up with either global or localized or local blueprints. But the key attributes for a blueprint are the fact that you can define machine resources, so things like memory and CPU and storage. You can also define within the blueprint itself where you want to deploy these virtual machines. So you have a collection of endpoints or a collection of resources, and you can say when you deploy this virtual machine or when you deploy this blueprint, I want it deployed only in these environments. So you can define that also within the blueprint itself. You also have things like quotas that can be tied within the blueprint. So it allows you to go in and set virtual machine lifetimes, or how long the virtual machine can live for, how much resources it can consume, and those kind of things. The other big plus that comes with VCAC and the blueprint mechanism is the fact that you now have a way of providing an approval policy, so that you can say you need approval for these particular steps during the deployment phase. And I'll show you those steps in a little while. It's also good because it provides build information using extensibilities in the workflow process during the deployment phase. So there's sections during the deployment of, say, a VCAC application or a blueprint that allows you to inject things so that you can exit the process of deployment, go run a couple things like create an environment, provide other attributes, come back and continue with your deployment process. And part of the things that you can do during that phase is you can go out and you can request approvals, you can request for physical attributes to be available. When they're available, then it can continue running the deployment. And there's also security embedded within the blueprint itself, which allows you to go through and define what things are permitted on a per user basis or on a group basis or those kind of things. So the concept also, these were the steps that I was talking about in terms of when you request a machine, you have a way of escaping that and running something like requesting an application, goes out and pauses and waits for an approval for that to happen. During the provisioning phase, you can have a pause in it that says, okay, I'm going to go out and figure out whether all my physical attributes are in place, my network is available, and then come back. And a lot of those workflows are done using VCO, or vCenter Orchestrator. So this kind of shows you the blueprint information, which is how you define your blueprint, and you have things like the cost associated with it, how long you want it to be archived for after it's been deployed, things like machine prefixes, so that when you're deploying virtual machines using this blueprint, it'll prefix the machine names, whether you've defined a script for defining them or not, with a specific prefix. The build information gives you things like customization on how, when someone deploys this virtual machine, they can define or request changes to it. So that unlike a template in Virtual Center, which is a static entity, a blueprint gives you the flexibility to enhance the virtual machine configuration. So in this case, if I was the builder of this blueprint, I could go in and create minimums and maximums. So that for this case, I would say, when you deploy this virtual machine, minimum 1 CPU, maximum 4. For the least time, you can start off with a day or 2, but nobody can ever request more than 3 weeks. So I can define those things, and a user can choose during the deployment process which of those attributes they want to change or not change. And obviously, associated with each one of those changes would be an approval process if you want one available. So that by default, if you deploy the minimum, you don't need an approval. But if you want to change any of those minimums, then it has to go through an approval chain. And the security one, these were all the different attributes that you can set within it. So as you can see, the blueprint option gives you a lot more flexibility and a lot more options and a lot more granularity in terms of securing and managing your application deployment process. But again, the blueprint process is still a deployment process. It's not a life cycle or a lifetime definition of that particular virtual application. And what I mean by that is, again, once you deploy it with VCAC, it's very difficult to go in and modify that application. Say now you've deployed a blueprint and it has a database, a web server, and a backend system. And now you want to enhance that blueprint so that future ones can be deployed exactly like that one. You'd either have to take the application, modify it, create a new blueprint, or take your blueprint, modify it, and then create a new blueprint out of it. So there isn't a lot of flexibility in terms of management of that blueprint after the fact. So the concept of a machine is the result of what an end user would request. So you'd go in and you'd say, I want to deploy this blueprint. The end result of that is the deployment of machines, whether they are virtual or physical. Or they can even be cloud-based virtual machines, depending on the kind of endpoints that are available within VCAC. Day 2 operations are permitted, but that is usually dictated by the security settings that are available in the blueprint itself. So that if I say you cannot stop this virtual machine, then you have no interaction for controls of that virtual machine. Once it's been started for you by an admin, you can only interact with it. And machine reclamation is also based on the lease that is defined within the blueprint itself. So the machine deployment screen looks kind of like this, where you have the name of the virtual machine, and this is through the VCAC portal. So that now you have deployed a virtual machine, and at that time you can enter some aspects of it. You can see what your storage definitions are. You can change your network settings if required, or you can go in and look at your execution environment if needed. There is also an option, obviously, to request new machines, which will give you a listing of all the available blueprints that are there. So machine operations are also another aspect, and these ones are also dictated by the security settings that will be defined within the blueprint itself. So blueprints are usually set up for individual machines so that you can go in and request a machine. But then there is an extension to that, that is the multi-machine blueprint. What we found out with the last couple of versions of VCAC is that VCAC requires multi-machine blueprints when you are integrating with NSX, because the only way you can request NSX attributes is if you're using a multi-machine blueprint. Whereas if you're using App Director only works with single machine blueprints, and as such, you can't use App Director with VCAC and NSX. So there's still a couple of things that need to be merged together, and it's part of why we need to come up with a definition that works across all the different platforms for defining virtual machines. So the multi-machine blueprint itself is a model for application development, so that you can go in and you can create multiple machines hooked together as a single blueprint that can be deployed at the same time. You can define the type of networks that go into them. You can define relationships of those applications, as well as scaling factors are involved in it. It's a way to aggregate at the multi-machine level. So going out and defining an envelope or container that says, this is my blueprint now, but instead of just deploying multiple blueprints, you can deploy one blueprint that has either other blueprints embedded in it, or it can be definitions of individual virtual machines and their interconnections. The network tab in it, and this is for the multi-machine one, will allow you to do network selections as well as load balancer selections and definitions for them. And for the network selection, these are all done during the creation of the blueprint itself. So basic load balancer, and this looks very similar to like the vShield interface that you would see, but it's obviously a different type of load balancing option available within VCAC. But it does give you health check information as well as port and virtual machine, inside virtual machine definitions for it. So App Director virtual machines. App Director is slightly different from VCAC in that its blueprints allow you to create logical applications. So you can go in and you have menus of different operating systems as well as applications, and you can create interconnections between them. You think of it as being made up of nodes, where the nodes could be things like app servers or database servers or web servers or individual like TCL servers if you want. But the nodes are logical templates. And you think of the nodes as containing the building blocks that are required to encompass the components themselves. Internode dependencies and property bindings, as well as, those are also part of the packaging that's available to you. And some blueprints are deployed in multiple environments, meaning you can create the same blueprint and develop and deploy it in, say, your dev environment, your test environment, and your prod. The build environment looks sort of like this, where I can have a selection of my operating systems. I can pull them into the different nodes and set up the interrelationships between them. So that kind of covers the different packagings that we have. So we talked about the OVF packaging, which is sort of a standard out there that allows you to move virtual machines between platforms and environments. We talked about vCenter packaging of vApps, whether it was a single machine or multiple machines. We also talked about VCD packaging and how that's different, and VCAC and App Director packaging. But you can see that every single platform that we've talked about has its own individual definition of what an application is, its own understanding of what an application is and how it interacts with that application. The biggest issues with most of them is the fact that the definitions are not portable across the platforms. And that is a problem that we internally are recognizing and need to come up with a good solution for. So the part of the working group that I'm involved in within the Office of the CTO is the fact that unless we can come up with a good definition that works across the board, it will be very difficult for our developers to implement it. So based on customer feedback, people like you, partners and customers, we can come up with a good definition, one that will work across all the different platforms, will be easy to deploy, and will be flexible enough to allow you to be able to deploy your applications, define all the different attributes that you need within that application, and make it portable so that once I've defined an application constituents, these are my virtual machines that go into it, these are my operating systems that go into it, these are the network interconnections, my storage requirements, my CPU requirements, all those things. I can encompass that in a definition of an application, deploy it in Virtual Center, and it works. Export it or move that application to a different platform like VCD, and it works. Take it and put it in VCHS as an example, and it'll continue working without me having to constantly go into the application, change attributes about it to satisfy the runtime environment or the platform that I'm deploying it in. Does that make sense? Yeah. So looking at what the future of an application is, it's all those things that I've talked about, including the flexibility of a good UI to define those aspects and a good way to create them. Whether we use tools like VM Studio to create the application or whether we have those tools built into the platforms themselves. But it has to be easy for you to be able to go in, define that application, encapsulate it, and not lose that information about the application when you deploy that application. In other words, it's not a deployment environment. It's actually a definition that moves with the application, right? So deploy it, the definition sticks. You don't have to go through the motions of deploy, export, import. No, it's a matter of taking your application definition and saying, I'm moving you to a different environment and being able to be absorbed by the platform and run that way. So some of the needs that I have is a unified application construct. And by that, I'm talking about that whole definition that encompasses everything that would be important when it comes to defining what an application is. It needs to be used by all the platforms that we have, as well as external platforms. And by that, I'm saying, if we can come up with a good definition, we can provide it to the IETF, it can become a standard, if possible, that other vendors can deploy and implement. So it gives you the flexibility as the user of defining a VMware-based virtual application that you can move into VCHS. If you decide you want to run components of it within AWS, it'll be able to move into AWS. You still have all that flexibility. So one of the options we were looking at is taking the VApp definition that we have either in vCenter or VCD and enhancing that, making it so that it's more powerful than it is right now and platform agnostic. Or taking the OVF2 definition that is already out there and using those extra features that have been embedded in the definition for it for things like placement groups or scale out settings. Because there's nothing worse than deploying an application, say it's a 3-tier application with front-end web servers, and then finding you need to be able to scale that application, either scale it out or scale it back. Within the definition of your application, you should have an automated way of doing that, right? Because it's just common sense. If I get to certain thresholds, I want another web server deployed. All that stuff should be dynamically available within that app definition, at least the way I see it. So scale-out settings should be one of those aspects that should be included into it, as well as the placement options. So that I say, when you deploy this virtual application, these are the kind of storage thresholds that I want to be able to meet. These are the kind of CPU gigahertz that I expect to be able to consume, and I want to be deployed in an environment that provides me a minimum CPU of that kind of threshold. So some of the features in vServices, and just based on your response as in terms of knowledge of vServices, that's why there's a big question mark on the end of it, in terms of what is the future of vServices. Being an awesome platform and all doesn't make it a consumable platform. If most of our users have no concept of vServices, and even our internal developers aren't consuming the vServices that are already available, then maybe it's not the way to go when it comes to defining applications and application interactions. But it is used by some critical services within the vCenter platform. The biggest question that I always had with it is that if it is deployed within vCenter, you've now limited yourself to the scale of vCenter. What if we removed that capability or the requirement of a vServices platform and put it into what we might call core services. So that when you deploy a VMware environment, you deploy a core services which provides all the interaction that you would need. All the requirements for the platforms that we have would be provided by the core services, and you'd be able to consume those from any of the platforms that we have. If vServices was put into the core services, then it would be easily consumed by any platform, not just platforms that interact directly with vCenter. So for vServices to continue, that has to be removed from vCenter so that it can scale a lot better. So the option of coming up with an open platform was what I was thinking in terms of combining the OVF framework that exists with the scripts that are required to do the injection and make it one encapsulated package. So that when you define an OVF environment, you define the scripts that go along with it, and those become portable. So that it's not a matter of being able to inject those scripts into the OS, but the OS calling those scripts so that it can run the processes that are required. And the examples are the usual ones, like setting an IP address within the VM, being able to pull in and upgrade a virtual machine on the fly, so that within the definition you would say, okay, upgrade me or check for updates every now and then. When those updates are available, there's a process within the definition itself for doing in-place upgrades or in-place changes. And that goes along with things like scale out and scale down of the actual applications that have been defined. So being able to create this open framework actually does complete the OVF story in terms of customization and makes that whole customization and extensibility of the OVF definition complete. It also makes VApp authoring easy, because now all you're doing is going out and creating or saying that this is my VApp. These are the basic building blocks or operating systems that I want within that VApp, and then adding on all the different brick components that you would need. And the brick components would be aspects or extensions to the definition of your application. So you start off with an OS definition that says I need a Linux box and I need a Windows box and I need X amount of OSs of that type. On top of it, you will layer out the bricks for building out a web server, a brick for building out a database, and then the connectivity requirements and the storage requirements. And all those are just aspects that you can pull off the shelf to create your application. Tie them together using the OVF definition, and now you have an application definition that is easily portable. You should also be able to apply this to running VMs, so that once you've deployed it, you can make changes to the environment and be able to consume them within the running VMs without having to power them off and restart them. So you can do things like in-place upgrades of your application without having to shut down all your virtual machines within the app. Gives you a lot of power when it comes to defining applications and how the internal components of them interact with each other. The other option, obviously, is to converge the VApp definition of AppD and the VCAC blueprints and come up with something that works on both platforms. But then again, that would allow you to have an app definition that only works within the AppD and VCAC environments. Even though VCAC seems to be the direction we are going in, there's other platforms that we have or other platforms that we might acquire that would not be able to support that. So we need to come up with something that, did I run out of time or something? So we need to come up with something that works across all platforms, which is what I keep stressing, I know, but I think that's a powerful reason for going out and doing it. So while we are in the process, we need to take up the opportunity to build for the future. In other words, be able to do things like support version control. Right now, when you do an OVF deployment or you create an application, there is no version control of it. You have to save that whole definition. And then if you need to change it, a lot of times it's editing the XML within that to change it and then redeploy it. But you need to be able to do things like version control of those blueprints. But to be able to do that, they need to be in textual form as opposed to binary form as they are in VCAC today. So challenges, you need to have a generic model as opposed to a domain-specific model. And by that, I'm talking about like a blueprint is a listing of things. And these are things that are specific to VCAC or AppD, as opposed to a listing of tiers and the bricks that I was talking about and how to interact with them. It needs to be generic enough as opposed to being the specific requirements that you have within your blueprint. And it also needs to be diverse to meet all the diverse use cases that we have there for different types of deployment for VApps, whether it's pure IaaS, database as a service, or even X as a service when X is defined later. And it also needs to be usable by a diverse persona, meaning it shouldn't be just an app definition that works for the sysadmin, but it should also be able to work for an app provider, a vendor, governance requirement, fulfillments, those kind of things. So these are some of the use cases that I'd come up with, and you can look at them, you can give me feedback on other use cases that you think need to be met by applications. Meaning, like in this case, I'm saying one use case for an app definition is that an app vendor can publish a VApp that can be easily deployed. Meaning they need to be able to go there, define that VApp, and give me the flexibility of deploying it wherever I want. Whereas now when they give it to me in an OVA format, I have 2 or 3 choices of where I can deploy that, right? Things like backed up and restored to a different environment. If I have a virtual or an application definition, I need to take that definition, back it up, put it in storage, be able to retrieve it from there and deploy it again as an application with all the tie-ins and attributes associated with that application when I pull it back from tape, right? So that definition needs to be sticky in that way. Things like it needs to be easily migrated from the customer site to the cloud, and the cloud is in quotes here. And I'm insisting that you need to be able to do it back. So be able to take it to the cloud, use it for a while, bring it back on premise, use it, and give you that flexibility of moving that application. Yes, today we can do all that at the granularity of a virtual machine, but not at the VApp level. So it's giving us that maturity of it. And obviously the biggest one, it needs to be able to be decommissioned. So that when I say I'm done with this virtual application, I don't have to go all over the place cleaning up things after it, right? So that now when I delete it, it goes through and cleans up after itself. So it needs to be able to be decommissioned cleanly.